That's right. All right. Oh, for those of you who applied for the VR think tank thing, the invites will come out sometime today. There was 38 applicants, and I think we're going to do like 10 to 12 people. So if you don't get picked, it's because you sucked. All right. Let's see, what was the assignment? List of scopes, but we talked about it last time, right? Okay, got it. So we can all see that. Good, because I can just almost see it now. Stretch. I don't wear those. Well, oh no, they don't make trifocal contacts. They do make bifocal contacts, but they don't make ones that also are for astigmatism. So you got to pick and choose. So I have single vision for astigmatism, which works out fine in VR, which is all I care about. I don't need to see this. All right. So we need to start off with updating our resolve and our extend environment, because our concept of an environment is now changing, right? We want to now have effectively a stack of scopes, if you want to think about it that way, or a list of scopes. So what is a scope? If we kind of go back down here, effectively, here, let me just dump all this extra crap that I put there last time. So here's our old environment, right? Which is a list of two lists. This is really a scope, isn't it? So what I want to do is I want to toss the word global in front of that guy. So I'm going to say that we have our initial scope is the global scope. Now, the only thing we're going to change is our environment is a list of scopes. All right. So I just put the word global in front of our old environment, and now I've changed the name in my mind to say that is now a scope. And then I put that scope inside of a list. That list of scopes is our environment. All right, we're all good with that? All right, so now we got to go and make our environment stuff add up to that, right? Work for that. All right, so that means when we get a resolve, for example, it's going to take in an environment, which is a list of scopes. So I'm going to actually, I'm going to do this. We'll actually call this guy resolve. It's going to take a var name and an env. Now we're going to call this guy resolve scope. All right. And this guy, and what I'll do here, just to make sure our naming stuff stays consistent, I'll change all occurrences of env in there to the word scope. All right. So resolve scope works the same way as it worked before now, right? You pass in a list of two lists, and it will return either the value that's that you wanted, or or a false. All right, cool. So we didn't have to change anything there except for just some stuff, some words. All right, so now resolve is our normal resolve. Now it's still going to take the variable name we're looking for, as well as the entire environment in which we're looking for that variable name. And this guy's job is going to be to process through that list of scopes until we finally hit a scope whose that starts with a global. Now we can decide to handle the word global in the I'm going to probably actually handle it here at the resolve level, but we could decide to handle it at the resolve level, or we can decide to handle it in resolve scope. But so we'll see where this takes us here in a second. But my job here is to process through my my environment, calling resolve scope on each scope in that environment until I get something non-false. All right, so start off a cond, null, env. If I've run out of crap to check, boiled on the false, out of scopes, nothing, nowhere else to look, return false. I didn't find the variable you're looking for. All right, else. I have one of two situations. Well, I definitely have a scope. This might be the global scope. It might be the other kind of scope, a normal scope, a temp scope, however you want to think about it. All right. If it's the global scope, we know this is our last hurrah. If it's not the global scope, we can potentially keep going. So what I'm going to do here is I know I have a scope. So I'm going to say EQ, the car of the car, ENV, global. So if I'm looking at the global scope, and it's possible after we get through this, we could see that we maybe wouldn't have had to treat this as a special case, but this is the very least going to be pretty straightforward. Okay, so if I'm looking at the global scope, I'm not going to be calling things more often. I'm going to basically say, let's do this one last test, and then let's return a false or return the whatever the thing was. So if I'm looking at a global here, what I'm going to go ahead and do is I'm going to boil down to whatever resolve scope returns for the variable name I'm looking for, and I want the cdr of env, which will give me my list of two lists, but I actually want the cdr of that guy to peel off the word global. I want everything but the first element, which will be the actual list of two lists. So if I come down here, if I'm looking at this guy whose car of the car is global, then I want to call it's a list of scopes. So actually I want the car of that and then the cdr of that. So I want the cdr of that, right? I'm lost. What was that? Ninja. I want the cdr of that, the car of the cdr. No, the cdr, the CDAR, the cdr, the cdr of the car. Let's show that to you. So this is the car. This is the cdr of that. The list containing only the two lists with the word global peeled off. All right, so that's what we're accomplishing in that piece right there. All right, so I'll call resolve scope on that very last scope, the one that is as the word global, and that's my answer. Whatever that ends up being, if I'm still alive right here, whatever that ends up being, that's my final answer. All right. Else. If I'm in this else, that means I have a scope, and well, I have probably at least two scopes, right? Because the scope that is at the front is not the global scope. And since it's not the global scope, that means that we need to process it as if any other scope, but we also know it's not our last hurrah. So I want to go ahead and call resolve on that scope. So I'm just going to write that initially. And then we're going to wrap it with some stuff. So I'll call resolve on the car of my env. I need to pass it the var name as well. All right. So I'm going to resolve this var name with the car of env. Now that's going to give me either a value or it's going to give me a false. If it gives me a false, I need to keep going. If it gives me a value, then I'm good to go. What? Resolve scope. Thank you. I'm going to call resolve scope, given it the variable name on the first element of my environment, which I don't need to peel the word global off because it's not the global environment yet. All right. But I need to know what this answer is so I can make a decision. So I'm going to put this inside of a let. So I'm going to say let maybe something like answer is equal to that. So I'll store inside of a variable called answer whatever resolve scope on this guy returns. Then I'll ask the question, if answer is false, then I'm not done, right? So answer is going to be whatever resolve scope boils down to for this scope. And I'm going to store that inside of this local variable. Then I'm going to ask questions about that variable. I'm going to say, if I didn't find my answer in that scope, then what am I going to do with it? If I didn't find my answer in that scope, then I want to go ahead and I want to call resolve this function, passing it the same var name and passing it the footer of my environment. Right? Keep checking the next scope. I didn't find it here. Otherwise, boil down the answer. So I think that should be our resolve. All right. We are going to need to update extend env here as well, but I think these two things together should work pretty well. If we want, we can actually, let's go and test those real quick. So let me. Ooh. I don't know, like the way any of that looks. So there's our environment that is in this case, a list of two scopes. All right, I'm going to comment out these guys here for a moment. And we're going to go ahead and call resolve A on our environment, which should give us a 1. I'll resolve V in our environment, which should give us a 3. Make sure I wrote this environment right. It's a list containing a bunch of 2 lists. Seems reasonable enough. Let's see if I had to actually change my resolve scope. Because that error is here in resolve scope. Oh, resolve scope. Thank you. Well, I think that's the only one. So there's our value for V. And we'll just keep going on line. W. All right, so we saw that this more local value of A, actually I have two A's in this one, which is funny, but whatever. So now we can look up C. We should be able to get to 23 because that shows that we were able to get to the next, the global scope. So there's our 23. All right, so we do want to have the ability to extend an environment, but now extending an environment, and maybe we change this up a little bit and really think about some of the tools that we're going to need for this. So now if we give it an environment in the right format, we can now resolve within that environment, right? Things are good there, but we do need the ability, especially when we're thinking about, we're going to be calling a lambda. And when we call a lambda, a new scope is created. All right, so really our old extend env, which took in a list of vars and a list of values, this guy is actually now, he's like a scope builder, right? He's going to give us a scope from a list of vars and a list of vals. I don't remember if we use that anywhere in there right now. We have to. We have to use it inside of our, it also gives us our initial environment. I'm trying to think ahead a little bit if we're going to need to extend the scope. I guess it's not going to hurt anything. We can just pass. We can have this thing called extend scope and pass it. If we want to start with a brand new scope, just pass it an empty scope. So we can even say something like define empty scope is the empty list. That way we just have like a global variable, defining the empty scopes. When we see it inside of our code later on, we can say something like, well, I'm creating a scope here, and technically the way I create a scope is by calling extend scope, but I'm going to extend the empty scope. That's the dude I'm adding stuff to. All right, so we'll call this guy extend scope, and he's going to take a scope as a parameter that we're extending. This guy's called extend scope. There you go, there. Okay, I think that's good for our extend scope. So this allows us to build up a new scope, and then we also need to have the ability of adding that scope to our environment. So that's where we have something define extend env is going to be a lambda that's going to take in a scope and our current environment, and he's going to boil down to the cons of scope onto RENV. Because that's what it means to extend an environment right now, is you just add the scope that we're extending onto the front of the list of environments that we currently have, list of scopes that we already have. Now we could ask the question, well, why didn't we just put this inside of our code like this? Well, because if later on we want to change the structure of our environment, we just have to mess with these functions right here. And all the code that we call later on will just still work, right? Even though the logic here has altered. All right, so extending an environment will take in a scope and the existing environment, and it will cons that new scope onto the front of our existing environment. All right, whereas extending scope does the same thing as extend env used to do, where it just takes in a bunch of variable names and a bunch of corresponding values and gives you a list of two lists with all that stuff in it. That's a scope. All right, cool. All right, so now, let's see, what was, where am I using these guys? Yeah, so that guy is going to, I'm trying to think with lets, because a let is going to have its own local environment, but does that environment, we're probably going to want to make that environment a new local scope on the previous environment, and then utilize the same tool that we're going to be doing here for our lambdas to say, as long as this let exists, we have this new, more local scope. As soon as this let's over, which can't really happen for us right now and going on to bigger and better things, but eventually we might say, you know what, I might want to have some code that does this, and then it does something else, and then it does something else. We might want to revert back to older versions of our when the let ends, we no longer want the scope that was associated with that let. We want to be able to peel back away from that guy and get back to the previous generation of it. All right, so we may end up not using these guys, but let's just leave it there for now, since we're going to be focusing on the lambda portion for this assignment. It's not hurting anything right now. All is being used is for the implementation of our let in our code. Okay, so I have my extend D and B. So now we have to start thinking about the tools that we're going to need for manipulating our environment inside of our lambda. So one of the things we need to be able to do is we need to be able to take an environment and strip scopes away until I get to the global, right? So we might call this, we might say define, because I mean, that's really something that's probably going to be useful in a lot of different places. So it's worthwhile putting that into a function. Okay, so we might say define pop to global, something like that. Sounds like a fun expression name, right? Pop to global. That should be a song. It really might be. Sounds German. Like an Oktoberfest type thing. Pretty sure it's all accordion stuff. So this guy's all right, so this guy's going to take in an environment, and an environment is a list of scopes, and it's going to start peeling away scopes until we finally get a car whose car is the word global, right? So if the car of the list and the car of that guy is the word global, if I'm looking at the global environment, done. There is your pop to global environment. It's this dude right here, which is a list containing a single scope, which is the global scope. Otherwise, pop to global, coterie and B. Right? That guy will do it. I think that will accomplish it. All right. I think that's all I can think of right now that we're going to need up here. We can always revisit this area of the code and add more environment helper functions if we bump into a need for them, but this is the clear stuff right now. All right. So questions about any of that? And let's actually, just for the sake of argument, I'm pretty certain this works, but let's pop the global on our environment. Yep, there's our original environment here with our first scope peeled off. And we can make sure it works for, there's a whole bunch of extra scary scopes added to, well, duplicate scopes, but still peeled to global. All right. So do we need to change anything in our parser to change how lambdas work? Lambda's a lambda, right? Nothing in our syntax has changed here. All that's changed is how we utilize our environment. So now we get down to the interpreter, and right now we're focused in on the lambda portion of this. But like I mentioned before, you didn't have to do it for the homework assignment because we're just going to purposely leave lets out of it for, because we wrote let already, didn't we? We wrote let in our language, or we did not? Yeah, okay. Yeah, so for the homework assignment, you didn't need to update the let portion of the code as well. But given the fact that let also manipulates an environment, we probably want to revisit that guy as well, but we'll do that as the sequel to what we're going to do right now. So right now, our focus is on our lambda expressions. Because whenever we get a new lambda expression, what happens? A new scope is built, right? All right. So let's do mathy stuff, I think, right? Run parsed code. And then here is, where's my, where's lambda? It's not lambda, it's called call, right? All right, this guy. What's this in? It's semicolon? That's for, yeah. This is function. This will help me. Lambda code stuff. LOL. All right, so what was I talking about? Oh, this. So run parsed function code. We're going to pass in. So we actually wrote our own helper function for this. Oh, this is good. So run parse function code is going to take in the catter of this guy, which is our list of well, I just want to see something real quick, please. No, we're not going to do that. Didn't somebody have like an update to what do I need to fix in here? That all right, so we're good there. All right, I just want to see what my parse code looks like so I can write this guy. Got it. I hate you people. The percentage of my computer screen that I can actually make out is so small. That's way worse. That's just well, actually, it's not necessarily way worse. It's similar because I can see pretty decent at a distance. It's this. I know. I'm not that mobile from a twisting perspective. It's their first world problems, people. All right, so whenever we hit a func expression, I want to get up to this code. Is that what it's called? Func or call expression? No. Yes. Well, what? What? I'm in this else, right?
Yeah. The else says we call it.
Right. If I see call expression, I'm calling a func code.
Yeah.
So I'm dealing with func expressions.
Okay, cool. Yeah.
All right. So I'm going to run parsed func code. I'm going to pass that guy the catter of the parse no code. So if I'm looking at something here that looks like this, the catter of this guy, does it let me get the, oh, that's terrible. Why won't it let me get the, yeah, I'm doing that. Ninja. Ooh. It's not good, but it's okay. So if I have a call expression, where's that guy get me? Yeah. So the car of the cooter of that call expression is what I have highlighted there. All right. So that is what is getting passed into run parsed function code. I'm passing it the car of the cooter of our parse no code, which will be this stuff. All right. And then I'm passing it this extended environment with this, and this is where it is getting our, so this map crap, this was stuff that allowed us to put extra variables onto. So here. Right. So this gets this is our list of variable names. This is our list of values associated with those variable names. All right. So really what we want to do with this is we want to build a scope. So let me get that piece in there. What did I call this? I called this extend scope, right? So I want to extend scope with this guy. And extend scope doesn't take in an environment. Instead, it takes in the empty scope. I'm building a scope. Then I'm going to take called extend env with the scope I just gave it and the current environment that we're extending. So I'm going to extend our environment with what? With a new scope that is this list of variable names and this list of values that have been evaluated, right? That's what all that map crap is doing. It's calling our run parsed code, whatever, on each of the values associated with it, since variable values could be expressions in and of themselves. So this is producing a list of variable names. This is producing a list of values. Those are the things that we're going to pass to extend scope, along with what scope am I extending? I'm building a brand new scope that is the scope associated with this particular function. And that is going to be the empty scope that I'm extending. Okay. And then what am I going to do with that scope? I'm going to extend the current environment with this new scope. That's what that does. All right. So what gets built right there is a new environment. Well, is it an extended environment with our brand new scope as the car of it? So this guy is now in a format that we can pass to resolve env, and it will look for our variable across the various scopes that are in there. All right. And I'm running my parsed function code on, this is the actual function. Where did I write that guy? That's this guy right there. That's the actual function that's being run, right? Okay, so this catter of parse no code is what I have highlighted down there. That's what's getting passed in to this dude right here, run parsed function code. All right, so run parse function code is going to take in our parse no code functions. This is an actual function, along with the environment in which we should be executing that function, which is now our newly extended environment with a brand new scope onto the front of it. So we're going to run parse code on the car of the cooter. So that should be the body of our parse no code. Car of the cooter. Where did I have that written? So this is the cooter. This is the cooter. This is the car of the cooter, which is that guy right there. That's the body of it, right? So the body of my function here is the car of the cooter. And then the catter of that guy is the car of the cooter, which is the actual elements. I'm going to make this look way better. I don't like the way this is written right now. It's the right stuff, but the fact that we see it like this is garbage. It's hard to follow. Like I just had to go and walk back through it to find out what the heck am I dealing with here, right? So what we're going to do is we're going to put this whole thing inside of a let. So I'm going to say let, and let's call this body is going to be all that stuff. And we're going to call run parse code on the body in our environment. So if I really want to see body of function, I'm not sure that's necessarily better, but we'll just spell it out a little bit. All right. That way we know what this guy here is accomplishing. Because as we have it written there, it's right, but it's code that's hard to manage later on when you go back through it. All right. So this is the body of the function. So we're going to call run parse code on the body of this function. All right. So this is going to bump us into our issue here. So we know in our example here that I have two calls, right? I have where's my call function inside of here's my call expression. Here's my second call expression. We know that whenever we run into a call expression, the environment that we should be extending is the pop to global version of our environment, right? Not just taking whatever our current environment is and tacking a new scope onto the front of it. Before we tack a scope onto the front of it, we need to take our existing environment and pop it to global so that we're only dealing with the stuff that is globally available in the entire program, not the stuff that was maybe available in the previous function that maybe added some crap to this this lambda. So I'm going to use my helper up here I wrote called pop to global. So then down here inside of my call, when I'm extending my environment and I'm extending my scope, well, I'm building a new scope. I want to make sure that the environment that I'm extending is a popped to global version of that environment. I want to clear out any non-global scopes because I'm about to make a function call, and that function call is only going to have access to his own local scope as well as whatever was globally available in the entire program. Nothing that maybe had been inserted in between. Make sense? And we're going to see that happen in our example here. We're going to see that actually happen twice, right? So my original call expression, it's going to create a new scope on top of the pop to global version of my environment, which is going to do nothing to the environment because it already was just global. But it's going to end up extending that environment with a new scope. But then when I get to the second call to call expression, this guy is going to create an extension of an environment as well. But the environment he should be extending is the pop to global version of our environment, not the environment that has this previous guy's scope in it. Make some sense? All right, every function has access to his own local scope and the global environment. If a function was called from within a function, he doesn't somehow magically get a pass through of the local environment of the previous function. So I'll make sure whenever I'm inside of a call, this is the Lambda code. We'll say Lambda, call Lambda code stuff. Whenever I'm in a call expression, I'm extending my environment with a new scope on top of only the global version of my environment. So we're inside of our run parsed function code, and I go ahead and get the body of this guy. The body, in our current example, the body of this function, which is a call expression, is another call expression. And it's that call expression that should actually execute inside of the original global environment with his own extended scope, with his own list of parameters. So we have a parameter R, and this guy is going to be bound to this guy right here, which is he will be resolved in the previous function's environment, right? A. So if I go to my actual code, where's my, so here's my call expression. So this guy is going to be a function that takes in a parameter A. Here's the body of that guy. Body of that guy ends right. All right. Yeah. So that's the end of the call. No. Yeah, we're good. That's the first parameter to the call. This is the second parameter to the call. So the second parameter to this call is the variable A. This guy should be resolved inside of the variable environment that was created from this first call expression. So only a call expression will be executed within the pop to global version of our environment. This other piece of it here, he's going to get executed inside of the extended ENV with the scope that was associated with this call expression. So where is it that we handle that guy there? That has to be. So if I'm in a call, I'm running parsed function code on this because I need to marry my is that going to be my this is another place where we probably wanted to have a let. So I'm getting with this all of my variables that are in the parameters of that with this guy right here, my variable A. So I'm going to be binding this value. This guy's going to boil down to a value. He will become part of the scope that is the extension for my first call expression, which means that as far as I'm concerned, inside of this call expression, inside of this function, I have a variable a that's going to be equal to whatever this guy resolves to, which should be my global a, which is the most local version of that. Oh, I guess I have a is 7, so that should be equal to 7. So I'm binding the value 7 to my local guy, which will be 7. So that's going to create me that dude there. I'm just creating the actual environment, what it'll look like. So my new scope is a function that has a binding for a is equal to 7. Why 7? Because that was the current value of a right here. My inner call, where am I at here? So now I'm inside the body of this guy. So while I'm inside the body, what I have right, yeah, that's the body of that guy. So this guy is going to be executed in this environment that I have written up here. And this guy is going to be, actually, it's that guy. That's the body of my first call expression, body of the function. That guy is going to be executed in the environment I have defined up here. Exactly, in that exact environment. I've extended it myself. Okay, I've visually shown you what the extension would be. So when I extended my environment with the new scope, I created the new scope a is equal to 7 because that's what we had here. This outer function had a parameter a, and his value was, oh, actually, I gave him his value was this lit expression, right? So his lit expression was actually 5. That guy, right? Yeah, so the value of that binding up there was this guy right here. So a was equal to 5 in my new scope. So now when I get to that inner call, the body of my first function actually has another call inside of it. So when I call that function, which is creating a new scope with an R and a value associated with the current value of a. The current value of a is a 5, right? So I want to make sure that guy boils down to that current value of a. And it's going to with that map, because the map is going to go and resolve all those things in whatever environment he has access to, which is now going to be the environment that I have right up here. That's the environment that this stuff right here is working with. That call expression is working with the environment I have defined up there. Okay. Now, so that'll create that binding. But when I extend the environment in which this guy right here is going to get executed in, actually, it'll be that guy right there that'll get executed in. That environment is going to be the pop to global version of this, which is going to give me a, well, pop to global. We'll peel that off, and then we're going to add a R is 5 there, because I am binding a value R to the current value of a in the environment in which this call was called from. And in that case, a was 5. But then when I actually execute the body of this guy, I'm going to be executing it in that new scope. This scope right here, that scope is extending the pop to global environment. That's why the a equals 5 disappeared. And I only have this more local scope available here. Okay, so that's all good. This was my parsed code. And we'll run it. All right, so let's just make sure this guy is what we want. So we're going to extend our environment with the extended scope, with this new dude, with this map, blah, blah, blah. And that guy will run inside of the pop to global. So that's what I was just talking about. So that A is equal to 5 was resolved inside of the current environment. The environment that did have that new extra scope on the front of A is 5. And only when I went to actually execute run parsed function on this guy, did I extend my environment with the extended scope that was built on top of pop to global of our environment. So what should the answer of this guy be? The body of this says to boil down to the value of R. Okay. Oh, but then boil down to A, where A is the inner value of A, which is 7. Right? But if we were to change this to R, then it would be 5. Right, so that's the homework, right? All right, does that make sense? I know that was kind of twisty and turny, but the magic that's happening there, forget about the nightmare of the maps. I mean, it's amazing, but I get that that's maybe a little hard to follow. Ultimately, we know that the nested maps there, what does it do? It creates a list of variables and a list of values. That's what it does, right? Okay. But the important aspect of that is this list of values that it's creating is happening inside of the environment prior to me popping to global. Which means I'm benefiting from the local value. A is equal to what I have 7 before, or no, it was 5. A equal 5. This dude right here. That was my original binding for A, right? So I'm benefiting from that new most local scope. A is equal to 5 before I peel away that scope to create my new scope that sits just on top of the global scope. This allows me to have nested functions. So I could have function inside of a function inside of a function. But whenever we call a function, the body of that function will execute inside of an environment that is only the local scope of that function on top of global. Even if we use the local scope of the function that was the parent to get us the value of a value in the new scope, like we did right here. For this function, when we bound R, we asked for the value of A. And the value of A there was actually bound in the local scope of this function. I still had that when I created my new scope. But then, so as I was creating my new scope, I grabbed the current value of A, which was 5. But then before I took that brand new scope and extended my global environment, extended my environment, I blew away the current environment down to just the global scope. And then just put the new guy on front. All right. So questions about that? So what was the tricky part with this? What made this extra difficult? Okay, now when you say overcomplicating it, where did you run into overcomplicating it? What do you think you tried to do that you didn't need to do? Keep in mind, I saw your code, so I know what you did.
I think the main issue was trying to not use functions and do it all.
Yeah. Think about, I mean, a majority of today's class so far has been doing what? That's not going to work, right? Let's just go to the bottom part. that stuff, right? We updated our resolve. We added a resolve scope. Well, we actually updated resolve to be resolve scope. We added a resolve. And then we just created these couple helper functions. Those individual tools in and of themselves were not very difficult to write. So we ran out to Home Depot. We got ourselves all these little widgets that let us do some stuff. So then when we came down here and we got to the meat of the problem, we were able to just use those little functions like, oh, what do I want to do? I want to extend my environment. What do we extend environments with? Well, we extend it with scopes. How do I build a scope? I got a tool that does that too. So by giving ourselves all these little tools, we remove that extra complexity that's involved in this problem. If you were to take all of this logic and try to squeeze it into one magical function, which you could make work. We could just take these lambdas and squeeze them all together and make all that work, that stuff work and chain together. It's going to be super hard to follow, and it doesn't give us any benefit. Make some sense? So similar to the exam, when we were talking about, helper functions, they're your friend. And plus, you might be able to reuse them for something else. Sometimes your helper functions can serve multiple purposes. I think several people on the exam, didn't you use, you had written the greatest divisor, right? In a previous question, and some people use that in a later question. You got the tool, might as well use it. No problem. Was that the map solution to that later one? I don't know why people are terrified of map. Well, that makes it good. Well, just because you're terrified of it. We already covered today. You're terrified of everything. Because post-Halloween, 21 years ago, you're terrified of everything. All right, so, so there's just out of curiosity. Come back down here. Where's the double map? Here's the double map. Why did we have two maps here? I'll space this a little bit better. So what's the purpose? And look at my variable names. What does map do? Tell me the generic version of map. What does map accomplish? Okay, take it one step further. What are the requirements of that function? One parameter. So map only works. So map takes a list as a parameter and say and a function. It says I will apply this function to each element of this list, where each of those elements become the single parameter that gets passed into that function. So the implication is the function must take a single parameter. We needed our function to take two parameters. That's not how map works. Map requires a function that takes one parameter. So why did we have two maps? Well, I made my one parameter a packet, a list of two parameters. But since it's a list, it's one parameter. So inside of here, what did I do? I created, where's my, this is what it does in there with the thing. So my inner map does what? It takes in a single parameter, X, and builds a packet, builds a single list with X and my current environment in it. So almost think of that like a pill, okay? So it's a packet similar to how computer networking works. When we send stuff over a network, we're sending it in packets. You got your data that you're working with, and that data is divided up in a certain way, but that packet can also have some extra crap on board that might help out with protocols like TCP/IP, things like that. All right. So we're saying, look, I'm tossing things down the network path, and these things are single things. But if you peel them apart, there's stuff inside. Okay. So what I did right here is I built a single parameter that actually holds two parameters. That was the purpose of that inside map. Just go through and give myself two lists with the value I wanted and the environment I needed. So that external one says, I will take in my single parameter, which is a two list. And then inside of there, I could use the first element of that two list and the second element of that two list. So we needed the nested map in order to use the inner one to build the pill, to build the packet that the outer one could then use as its single parameter. Does that make some sense? Okay. So when you break it down like that, it shouldn't be that bad. Now, could we have written a helper function to do that? Could we have created a helper function that just says, I don't know, packetize the values or something? Sure, but you still would have needed to pass it the external environment. So it would have had to have it. In fact, you would have then had the problem of having to make that a global variable. This allowed us to not have to make it a global variable because it was in our current scope. So this actually helped us quite a bit in terms of not having to write, not having to pull this guy out to something else. We would have had to operate off of that global variable name, which we really don't want to do. We could do it, but we don't want to do that because right now we're looking at environment passing interpreters. And environment passing interpreters require that you pass an environment. The presumption being that the environment you're passing around is the environment you should use, not some global external thing. All right. So I mentioned a few minutes ago that in our code right now, the other element that we will run into issues with our new scopy thing is let expressions. Okay. Remind me, what does a let expression do? Okay, so creates a scope. I mean, you hear me say it all the time, creates a local environment, but in our new naming convention, we would say it creates a scope that now lives as the most local scope in our environment. What if you had a let inside of a let? But do we need to pop the global? So let me show you a sample code of what I'm talking about here. How can I do? Well, let's just write it in scheme. So if I have a let that has an A2, B3, and then inside of there, I had a let that has a C4, a D5, and an AB. Oh, that's a good one. And I did something like that, B plus A. This should give me a 6. All right, this should give me a 6. But if I say E is equal to B, now it should give me a what? 5. So even though this guy established a scope, then this guy established a even more local scope. When I get to the body of this inner let, this guy is operating off of if we assume this is the beginning of our code, an environment with 3 total scopes in it. This is the scope at bucket 0, the scope at bucket 1, the scope at bucket 2. So what does that mean? Is when I made this inner let call, I did not pop to global. I built a scope on top of my previous scope. I just kept adding, because inside of the body of this let right here, I have access to everything that was defined here, as well as everything that was defined here, as well as everything that was defined here. So it does work differently than our function calls, because our function call transfers us to a new scope, where a let lives within the existing scope. All right, that makes some sense. So for our homework, here, let me get rid of that, make sure I didn't break anything. Working, well, I like to label it below it. Working scope function code. Okay, so for your homework, we're going to write, I'll put this in the slides. Update our let code to allow nested lets using our new scope based variable environment.
The previous version of the, would it already allow, oh, the code would have to already allow you to have multiple lets.
I don't know the answer to that. It's part of the homework assignment. So it might. Let me think about it. I do know the answer to that. The previous version should allow you to have multiple lets, because what let did is just called extend env, and just kept tacking more variables, and you would just run into, if there was 2 variable A's, it would be whichever one you hit first in it. So it didn't subdivide it into scopes, but it's still using our extend env. So you may not have to make major changes to that. I would say there's even an outside possibility it might just work now. Oh, right, you're still calling extend env. Yeah, so you'll have to change it a little bit, but this won't be as hard as the now that we have the code in this state, it won't be as hard as the other one. All right, questions, comments, concerns, bribes? All right, what day is today? I'll see everybody on Thursday. You're trying to